Hello. Hi guys. We'll start in a minute, and get your paper ready. Get your water, whatever snacks you're eating. Right? Be right back. 1 minute. You guys all ready? Hello. Alright, looks like we're good. Let's just get started then. So, today's lesson is not, it's gonna be a little bit, I would say slightly difficult in some ways because, it kind of requires brain, the thing you have on your head. Yeah. And it kind of, it's not like a one thing fit all kind of solution. Does that make sense? Or at least not at this point. Okay? So, we're gonna be using our brains, so, have that ready. So here we go. We are trying to find the 100th term and the nth term of this sequence, and if you look at it, oh hi Kevin, welcome. Finally see you commenting. That's great. Okay, so what I want you to do is tell me, is this arithmetic or geometric, or what do you see? What do you see here? So is this arithmetic? Is it geometric? Neither? What do you see? What's going on here? You add n plus 1. Interesting observation. So basically, if you pull it out, right? If you pull it out, let's just go with term number versus the actual term, okay? So if you go like, this is 5 terms, right? So I go 1, 2, 3, 4, 5, right? So then you look at this. I wouldn't say recursive. Recursive is something else we're going to talk about later on, probably 2 weeks from now, because next week's just spring break, right? So we're going to look at this. So 1, 2, 3, 4, 5, and then the actual number is 1, 3, 6, 10, 15. And then you look at their differences, right? So that's what? Plus 2, plus 3, plus 4, plus 5, like that, right? It's not exactly exponential either, because exponential is the same as geometric, which is multiplying by a constant number. Like, let's just say times 3 each time. Times 3, times 3, times 3. But it's not exponential, because if it's exponential, this will be 9 instead, right? 1, 3, 9, and the next one would be 27, because you're multiplying by the same number. But here, it's neither geometric or arithmetic for now. But you do realize, if you look at the pattern, the difference between them seems to be adding 1 each time. Okay, the difference between them. Okay? Now, because of that, let us try to figure out the pattern, because we are there's 2 levels, right? There's the difference here and the difference here. You can say in words that it is n plus term number, but what our goal is that when we, at the end of the day, we want some sort of formula so that when I plug in the term number, I will automatically get the actual number. All right, so that's the goal. So let's see what kind of pattern we can develop towards this. So what we want is called an explicit formula. Okay, explicit formula means that everything is well defined. Okay, so let's just see what pattern we can see. Okay, so we kind of want to figure out what is the make of these numbers. Okay, so let's just say the first one number is 1, right? Let's just start with 1. What is 1? Isn't 1 like 1 times 1, basically? So we're looking for something times something, okay? When this happens, we're looking for something times something. All right, so 1 times 1. 3, then we're going to 2. What's 3 in terms of 2? Isn't that 2 times 3 halves? Right? And next one will be 3, 4, 5. So we're trying to follow this pattern. Okay, so it would be 3 times 2. And then 4 times, I think this is 5 halves, 2.5, right? And then 5 times 3. At first glance, if you look at this, it doesn't look like anything, right? Doesn't look like anything. Doesn't look like anything, so you kind of need to fix the part, because some of them are fractions, some of them are not. Let's fix these into fractions. Okay, can we do that? So there'll be 2 over 2. They're all over 2, right? So we're going to do 4 over 2 and 6 over 2. Yeah, like Kevin Ma said, it's going up in halves in terms of the right side, right? The left side, if you look at it, is just 1, 2, 3, 4, 5, which is matching this side. So if you want to give a formula, then I would put n on the first part, and then the multiplication to the next part would then be what? How is this changing? How would I describe this change? So it's 2 over 2, 3 over 2, 4 over 2, 5 over 2, 6 over 2, right? So the index starts at 2, but my index here starts at 1, so I have to put an n plus 1 here, so that I can match the first one. And they're all over 2, so we put it over 2. Okay, so that would be your formula. Okay, let's see if it works. Let's look at, let's just say n equals, they want a 100 term, right? So let's just say n equals 100. Okay, n equals 100. Let me move this paper over. Okay, let's just say n equals 100. If it's 100, the 100th term, then it's 100 times 100 plus 1 over 2, which turns out to be 10100 over 2. which is 50-50. Okay. You can try a few smaller ones to see if it works. Let's just say 6. If you plug in 6, you get 6 times 7, that's 42 divided by 2, that's 21, right? So 21 should go the next one, which makes sense. Right, so the term number should work for that, okay? It's a little bit difficult, but let's look at the next one. So same thing, let's figure out the pattern first. Okay, so this starts with 2 instead of 1, right? So I'm gonna list it out regardless, because I'm gonna use the term number somehow. Okay, so I'm gonna use a table. So it's n here, and then tn here. Tn is the actual number. Okay, so 1, 2, 3, 4, 5, right? These are term numbers. These shouldn't change, okay? Then you have 2, 9, 20, 35, 54, right? So let's first of all figure out if the pattern is what we want. Okay? All right. So, this is a plus 7, this is a plus 11, this is a plus 14, 15. Right, wait, 15? And this is a plus 19. So as you can see, similar pattern has shown up. You're adding 4 each time, right? Like that. We're seeing it? Okay. So, let's try first with multiplication, right? So I'm gonna start with 1, 2, 3, 4, 5, okay? Because that's just how the term numbers are. So if it's 1, 2, 3, 4, 5, then the next one would then be what? 2, then what? 9 over 2. 3 to 20 is 20 over 3. 4 to 35 is 35 over 4. And then this will be what? 54 over 5, right? So if you look at it, there's no good pattern here, right? If you look at it, it's kind of bad, right? Because it's really hard to figure out a pattern here. Even you can't even common denominator, because the next one will be different, right? Because if you do over 2 over 4, then 3 and 5 won't fit. So this doesn't work then. So I'm gonna add 1. Okay, I'm gonna add 1 to each of these, because I can easily add 1 to my index. So I'm gonna do 2, 3, 4, 5, 6 instead. If I change it like that, what will be the next part? It will be 2 times what is 2? 1, right? 3 times what is 9? 3. 4 times what is 20? 5. 5 times 7 is 35. 6 times 9 is 54. You see a pattern now? What's the pattern? It's all the odd numbers, right? All the odd numbers. So then this will be, you added 1 to the index, so it's n plus 1. The right side is 1, 3, 5, 7, 9. How do I represent that? Do you remember how to write odd and even numbers? What is it? What is, how do I represent even number and how do I represent odd number? How does that work? Or you can even look at it as, this is an arithmetic sequence, right? Difference is 2. So that means it's something has to do with 2n. Right? But if you do 2n, that's an even number, right? If you plug in 1, you get 2, so you subtract 1. 2n minus 1. So odd numbers is either 2n plus 1 or 2n minus 1. If it's 2n plus 1, then you just, it starts with 3 in this case, right? But through 2n minus 1, we'll start with 1. Okay, so that's your formula, and you want the 100 term, right? 100 term would be 101 times 100, so it'll be 200 minus 1, so it'll be 199. So you multiply this out. Which is what? 299. Okay. So 2 answers. One is your formula, one is your term. All right. So why don't we try one? Let's try one. See how you do. So there's no like one right way to do this. As long as you get a formula that works, it works. Okay. The hard part is to figure out the pattern. Okay. And there is some variation in technique that I want to show you in this one as well. Once you're good with this. Is it alright if we find the same equation in a different format? Yeah, it's fine. As like I said, as long as it works for the sequence. When you plug in n equals 1, it gives you the first. If you plug in n equals 4, it gives you the fourth. It doesn't matter what the function look like, as long as it works. Okay. The ultimate thing is that it has to work. All right. Let's see what you come up with. Anybody have an idea? Or this one's a little bit difficult because of the, like, you can see where the pattern is, but it's hard to figure out kind of how to write the explicit formula, right? So, because it goes 1, 2, 3, 4, 5, and then you get 0, 2, 5, 9, 14, right? All right. So if you look at this one, the difference is still 2, 3, 4, 5, and then you do a +1, a +1, and +1, right? So it is the same exact equation. It's called a squared sequence, basically, because you always have something multiplied by something and it ends up in being a quadratic, basically. Okay, so we're gonna use the same method, okay? But 0, right? You see a 0 here? How can I get 0 by multiplication? How can I get 0 by multiplication? This is a huge clue. Okay, how do I get 0 from multiplication? How do I get 0 from multiplication? Something times 0. So instead of starting from 1 then, let's start from 0. Okay, we're going to start from 0. So because of this, we try this, okay? Then we go 0, 1, 2, 3, 4. Now, some of you are like, well, I kind of can't figure this out because this can be anything, because as long as this is 0, it's 0. You're right, so that's why we start here first. 1 times what is 2? 2, right? 2 times what is 5? 5 over 2. 3 times what is 9? 3. 4 times what is 14 is actually 14 over 4, which is actually 7 over 2. Huh, interesting. So let's try to modify a little bit. So this is the same thing as 2 is what? 2 is 4 over 2, right? 3 is 6 over 2. So you can see how the pattern goes. 4 over 2, 5 over 2, 6 over 2, 7 over 2. How is this going? So let's write it out. Okay, so this first part is subtract 1, right? And minus 1, because comparing to 1, 2, 3, 4, 5, 0, 1, 2, 3, 4 is subtract 1. Okay, and now this whole thing is over 2, right? See, the next part is over 2. 4 over 2 with 1. 6 over 2. Let me write down a term number so you realize what the index actually is. Okay, 1, 2, 3, 4, 5. Okay, so the index is 2. You are at 4. Index is 3. You are at 5. Index 4. You're at 6. So how do I represent this number based on index? Index is n. Okay, so it's n what? What is it doing? Plus 2, right? And plus 2. That'll work, okay? And that will be your formula. So that's one way of thinking about it. And obviously you can plug in 100 to get the 100th term. Let's look at an alternative method, okay? Let's look at an alternative. So there's an alternative. Alternative goes like this, okay? So, so same thing, 1, 2, 3, 4, 5, right? And then you see here, this is 2, 5, 0, 2, 5, 9, 14. How does this work? The difference is what? Plus 2, plus 3, plus 4, plus 5, right? Hey, look at your examples we just did on the top. Which one of them have the same pattern of adding? Which one of them have the same pattern of adding, which means that you are you're adding 1 extra each time. Which one? Example 4 or example 5? Which one is has a plus 1 pattern in your difference? Number 4, right? Number 4. Because this was what? 1, 3. So let's compare. Okay, so we had 1, 3, 6, 10, 15, right? How are they related to each other? How are they related to each other? 1, 3, 6, 10, 15 versus 0, 2, 5, 9, 14. How are they related? This one versus that one, or that one versus this one. How are these two related? 1, 3, 6, 10, 15 versus 0, 2, 5, 9, 14. How are they related? Plus 1, right? Or this plus 1 is that. In other words, or this plus 1 is that. So if I know this, do I know this? If I know this, all I have to do is subtract 1 to get my answer, right? But we already found this, didn't we? What was this? Wasn't it in your answer on number 4, which is n times n plus 1 over 2? That was the answer, right? And to get my new sequence that I'm desiring right now, all I have to do is subtract 1 in the end, okay? In the end, when I'm all done. So that would be also my formula. And you're like, Mr. Crow, these two are different, right? It looks different. Are they different? Are they different? Can I show if they're the same? You just you can multiply them out and then combine like terms, and you can show them they're exactly the same. Okay, or you can try to factor this, combine the top, and then do the factor. But these two fundamentally are exactly the same equation, but in different form. So that sort of answered Kevin Ma's question earlier about whether or not we have to write in a certain form. The answer is no, you don't have to write in a certain form as long as it works, like this one or this one. Right? Because we already know this. All we want is a formula that works for each index. Okay? Scale of 1 to 10, how hard do you feel this part is? This is all I'm teaching today. But from scale of 1 to 10, how hard do you think it is? Give me a number. Type. 5, 5, 6, 6, 5, 6, 24. What the? 6, 8, 7. So it's like a mid range. The hard part about this is that you really, like I said, the brain is important. Like you have to be a little flexible. Nathan says chilling. Or Kevin says chilling. Nathan says too. The hard part is there's no like a set of algorithm that always work. Like sometimes you have to make adjustments, and that's the difficult part. Sometimes I feel like we don't emphasize this skill enough to be flexible in math. Like we have a lot of algorithms to do problems, but this kind of topic kind of opens up for some flexibility. Although there are algorithms to solve this kind of problem, but I'm going to reserve that until later when we talk about series, because series has to do with each time you're. So anyway, so try to be flexible for now. That's pretty much it. So your homework is going to be you guys know, it's in the Google Classroom already. Let's see. Classroom. So I think I posted this like earlier this week already, and some of you already turned it in. I think, or actually nobody turned it in yet. I think it's from the other period. So it is under sequences and series 410 homework. It's due 410, which is tomorrow. But I mean, you do what you can. In the instruction it says general sequence page 1 to 4, which is this is the first page, okay, and then the rest of the 3 pages. The last page is only 2 problems, so really it's just 2 pages, okay. And just take pictures of all 4 that you did, and then you upload it, okay. Submit on Google Classroom. You guys all joined, right? All right. So I want to take attendance at this time. So if you're here, just type here. That way I can just count formally. I know some of you already said hi and participate, but I just want a head count real quick. Thank you. Let me pull out the chat on my computer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Who's Lucifer? Six. Still missing a few people. Who are you? Just tell me your name, okay? Tell me your name. Okay, let's see who's not here. Oh, Brandon. Was that you? I see what you're doing. Okay, Shravya. Yes, Ikanosuke. Oh, never mind, I saw him. You see Arjun? Arjun, are you here? Hi, Kevin. Arjun is AFK. I never seen him today though. Is he here? Arjun is not here. What's happening? Arjun, if you're here, make a comment or send me an email later when you watch the video. Please do it before 3:45 today. Thank you. He's here? He was here? Where is he? Is Jessica here? Jessica? I don't see Jessica. Fail. Tell him to send me an email. I don't see Jessica though. Oh, hi Jessica. I think everyone else is here. Yeah. Checked. Yeah, pretty good. Any final questions we have before we close today? everyone has some urgent questions about anything. As far as assessments and grades, I'm still waiting for info from the district. So as soon as I've figured it out, then we can talk about them. As of now, we have not decided on how to do grades in general. So for now, you can assume that we will not have any sort of high-stake tests for the school year. So, hi Sabrina. For test corrections, it's a little difficult because then then I have to take all the test pictures and send it to all of you individually, which is kind of a technical problem. So for now, and we don't even know how the grade's gonna structure yet. So as soon as I find out about grades, then I'll update you guys, okay? I know some of you are worried about like grades, like that kind of thing. Hi Arjun, I got you. So keep that in mind, okay? I won't leave you guys in the dry, okay? If you're worried about your grades, I'll try to figure out as soon as I know what they're gonna do with grades, and then provide some sort of information, okay? As for now, there's no test in the immediate future at all, and even if we do a test, it's probably gonna be like a participation, kind of like a formative assessment relative to summative. Summative is like you get graded and all that stuff, whereas formative is more like for kind of like a small quiz, but it's not like worth anything. It's just like for me to check your understanding. Okay, does that answer most questions, or like address most questions? I'm pretty sure some of the answers aren't answered because I don't have answers, but wait for info is my take for now. Oh, next week's just spring break. You have any plans? Oh wait, it's fine. I'm sure that you have plenty to do at home, right? How many of you have shaved your heads? I have a very strong urge to shave my head bald, like completely. Zoom call with a beach background. Yeah. Do it. No, if I do it, then nice, Allison. And the good thing is, even after you shave it, nobody would know once we get back. Or I guess the famous saying is, you gotta post a picture. Shave my eyebrows. Never in my life has bleach cut and dyeing hair is good for adrenaline. I mean, it's honestly kind of become a drag in the morning. Like I feel like my hair is keeping me from waking up because it's like too heavy. Yeah. All right, guys, I'll seriously consider it. But meanwhile, do your homework. Kevin, I think earlier you had a question about number 12, right? Number 12. Number 12 just looks bad, but in reality is actually not bad. Okay, there's a pattern that can easily construct. Okay, this pattern. Okay, don't overthink it. Okay, first when you see a sequence, you always want to first check arithmetic and geometric. Okay, even if it looks bad, like usually fraction is usually a kind of gives you a hint that it might be one of them, right? Because it, like, you can only get fraction by doing certain things, right? So keep in mind, keep an open mind. Arithmetic, geometric, check first. If it's neither, then you can start using your brain. Okay. All right. So, any last thoughts before we close? No, I see. All right. Stay safe next week. I'll see you in 2 weeks then. Yeah? You think? I'm running away, but you push me away. Goodbye. I'm here for you, babe. I've loved you the same this whole time. Have a nice day. Wow, that's high. Thanks, Kelly. Have a nice break. Bye, Allison.